What if I told you that a basic science lesson could one day save your life? Sounds pretty dramatic, right? But honestly, the ability to take a big, jumbled mess of stuff and sort it out into its useful parts, that is one of the most powerful skills we have. And today, we're going to put that skill to the ultimate test.
Okay, so picture this. You're stranded right here. It's blazing hot, you are seriously thirsty, and you're surrounded by this endless ocean. The cruel joke? All of it is completely undrinkable seawater. This is the ultimate survival puzzle. Panicking is not an option. Your only way out of this is to think. And lucky for you, science has already figured this one out. The key isn't finding water, it's making it by taking apart the water you've already got.
To solve this puzzle, we first need to understand exactly what we're dealing with. That sandy, salty ocean water isn't just one thing. It's what scientists call a mixture. And our survival totally depends on our ability to unmix it.
A mixture is pretty simple, really. It's just a collection of different things, all jumbled up in the same space. But, and this is key, they're not chemically bonded. Think of our seawater. You have water molecules, salt molecules, and little bits of sand all just sloshing around together. They're like roommates, not a married couple.
And this slide just makes it so clear. On the left, you've got a mix of different molecules. On the right, jelly beans. The principle is exactly the same. Just like you can pick out your favorite jelly beans, scientists have tools to sort out different molecules. The individual parts are all in there, just waiting to be separated.
Okay, so with our seawater mixture of sand, salt, and water, where do we even start? Well, the most logical first step is to tackle the most obvious problem, all that gritty, solid sand. So, how do we do it? We need a way to stop the solid sand particles while letting the liquid water pass right on through. Any ideas? If you've ever made coffee with a filter, you are already on the right track. The scientific name for this process is filtration, and the key words here are insoluble solid and barrier. Insoluble just means the sand doesn't dissolve in the water, and the barrier is our tool, something with holes small enough to let water molecules through, but way too small for the sand. And this shows you exactly how it works in a lab. You've got your mixture of salt, sand, and water. You pour it through a filter paper sitting in a funnel. The sand gets stuck, and the water, which remember, still has salt in it, drips through into the beaker below. Essentially, that filter paper acts like a microscopic sieve. The sand gets trapped, leaving us with a clear liquid in our container. We've just completed the first stage of our purification process. Great, the water looks clean. But if you took a sip, you'd get a mouthful of salt. We've removed the visible problem, but the invisible, dissolved salt is still there. This is where the real challenge begins.
This brings us to the next, and honestly, the more clever part of our solution. We have to separate two things that now look like one. The salt has completely dissolved into the water, becoming invisible. To separate it, we're going to need a technique that can pull them apart on a molecular level. A filter won't work anymore. The dissolved salt particles are so tiny, they'd slip right through the filter paper along with the water. We need a different approach, one that takes advantage of a fundamental difference between salt and water.
One method is evaporation. If you heat salt water, the water will turn into a gas, steam, and float away, leaving the solid salt crystals behind. It's a great way to get salt, but in our survival scenario, it's a total disaster. We just let the very thing we need to survive escape into the air. So the problem with simple evaporation, as you see on the left, is that the water escapes as steam. The solution, shown on the right, is brilliantly simple. We have to catch it. By trapping that steam and cooling it down, we can turn it back into liquid water. This is the leap from simple evaporation to a much more powerful technique. And that technique is called distillation. It's a two-step magic trick. First, you use evaporation to turn the liquid water into a gas, leaving the salt behind. Then, you use a second process, condensation, to cool that gas and turn it back into pure, clean, liquid water. It's like creating your own personal miniature water cycle. We boil the water to make a little cloud of steam. Then, we guide that steam through a cold pipe, which forces it to condense back into rain, pure distilled water that drips into a new clean container. The salt gets left behind in the original flask. And there you have it. Through a two-step process of filtration and distillation, we have taken a dirty, undrinkable mixture and turned it into the most precious resource on the planet: pure, clean, life-saving water. We've just seen how powerful filtration and distillation can be in a survival scenario.
but they're just two tools in a much larger scientific toolbox for separating mixtures. The right tool for the job always depends on the specific properties of what you're trying to separate.
For instance, if you have a mix of iron filings and sand, a simple magnet will do the trick, pulling the iron right out. Or what if you want to separate the different colored dyes in a single drop of ink? A clever technique called chromatography makes the colors race up a piece of paper at different speeds, separating them out. It just goes to show, for every mixture, there's a clever way to unmix it.
So, a desert island survival story is a great way to understand the science. But here's the most important part. This isn't just a thought experiment. For billions of people, this science is a daily reality and a lifeline.
I mean, think about it. Massive desalination plants, some producing over 100 million gallons of fresh water a day, use these exact same principles to support entire cities in arid regions. And on a smaller scale, simple but brilliant filters provide safe drinking water for families and communities all over the globe, preventing disease and saving lives.
This is the real power of understanding science. What starts as a simple principle in a classroom or a fun puzzle on a desert island scales up to solve some of the biggest challenges humanity faces. It is, quite literally, a lifesaver. So we've seen just how powerful the science of separating mixtures is. It gives us clean water, helps us sort materials for recycling, and even purifies life-saving medicines. This leads to a final, fascinating question. Now that we understand how to unmix things, what's the next big, messy problem this science can help us solve?